Space Centre with another edition of Ask an Astronomer. And today I'm normally joined by our astronomer Marley, who is on vacation, a much needed vacation. So we have a special guest with us, our head interpreter, Matthew. Hey, Matthew, how's it going?
I'm doing really well. Thanks for having me on.
Thanks for joining us, Matthew. So to let everyone know who you are here at the Space Centre, tell us a little bit about what you do as a head interpreter.
Yeah, so our job basically is to stay up on space news, what's going on out there in the cosmos, and then bring it to all of you who come here to the planetarium, but also are a part of our live streams. So we're kind of the front-facing team here at the planetarium. We're working with people both in our cosmic courtyard, which is kind of like a cool gallery space where you have a lot of interesting space things ranging from like a moon rock to asteroids. We're also doing live demos that are relevant to whatever's going on in space news that month. We also have our ground station where we have live demos that have done things like rocket launches that people can come and see. And then some of us are also working upstairs in our planetarium star theater, which is kind of our grand event, which is being flown around in our 360-degree dome. So one of us is always, as an interpreter, is in one of those three spaces talking with all of you.
Awesome, amazing. And you also do some freelance work out there in the world, writing for Universe Today. And so that's going to be what we're going to be talking about. You've written some articles, you've got some news stories that we're going to cover in today's show. Tell us a little bit about the work you do for Universe Today.
Yeah, so I always that was one of my go-to sources for space news, because Universe Today is a Canadian-based space science news magazine. You can find it at universetoday.com. There are a number of contributing writers, and I always wanted to be a writer for them. So what happened was, during the course of the pandemic, when everyone was kind of stuck at home, I was like, this might be a cool opportunity to do some space writing. And so I reached out to the magazine, told them about some of the other work that I was doing, including here at the planetarium, and got to come on board now as one of the writers. So it was a really exciting opportunity. I've been writing for them now for just over a year.
Wonderful. Well, Matthew, let's get going with some of our first stories. And we sort of have a theme for today's stories, some of my favorite topics. I'm pretty sure there are some of your favorite topics as well. And that is the search for extraterrestrial life, called SETI. And there's a bunch of news stories that have happened recently, some that you have written about, some that are about to be published. Let's talk about this first one. If we go back in time to a news story that you published back in, I believe, October, was it? Not this one. It is this one. The radio signal from Proxima Centauri. So Proxima Centauri is a star that is fairly close to us. We heard some signals coming from that star that some, not all, potentially theorized were coming from aliens. Of course, this is what we always hope when we hear about these signals coming from various stars. But we had some information about where those signals are actually coming from. So why don't you tell us about the story that you wrote, the radio signal from Proxima Centauri?
Yeah, so there's the Murray-Yang radio telescope in Australia, and it had been pointed to different targets in the sky. It was actually looking for super flares. So these are giant flares that are cooked up by stars and thrown into space. And they tend to also be created by things called red dwarf stars, which are the most abundant stars in our galaxy. Well, the closest star to our own is Proxima Centauri, and it is a red dwarf star. And we were looking at that star to see these mega flares that were coming off of it. We have these big bursts of radio signals that are picked up by this very dish that you're seeing right now in the stream. But something had happened because we were also looking through the data to see whether or not any of the signals that may be coming from our neighboring star could be interpreted as artificial. And there was an undergraduate student named Shane Smith who last year was going through the signals and found one that was screened by a piece of software called TurboSETI that is looking for signs of artificial signal. So one that's modulated by technology. This isn't a radio signal that could be created by any natural phenomenon. And that software is really efficient at screening out what otherwise might be a false signal. And so things like cell phone signals from our own planet, satellite signals from our own planet. Our planet is very radio noisy. And 1 out of 4 million signal hits was indicative of being from the direction of Proxima Centauri and possibly artificial. And so we thought, wow, we should really focus on this and see what's going on. And there's follow-up research done by Dr. Sophia Sheikh from Berkeley SETI Research Institute. They went and looked at the signal, they scrutinized it, and over the course of a year, we finally realized it looks like the signal is probably more noise from Earth. But what tricked us was that when we were pointed off the source, so this case Proxima Centauri, the signal disappeared. And that sometimes is a telltale that it's actually coming from that point in the sky. But it looks so much like some other radio interference that's local to that telescope that we can't say that it's not a part of the rest of that radio interference. So it is kind of anticlimactic, but at the same point, this is important because this is the process we need to learn how to do in order to make sure that we don't have more of these false positives in the future.
Now, radio astronomy is something, that humans have been doing, really in the 1970s. And I'm thinking back to the WOW signal that came out. So even when we first started doing radio astronomy, we started picking up these signals, and anything that was different, could also be interpreted as aliens, right? So are we still sort of like going through that process? Like anytime we see a signal that is not quite what we are used to seeing out there, there's always going to be that interpretation that it's aliens.
It's always like, this is the thing we want to find out there. But because we know that, we have to temper our own bias because obviously everyone always wants it to be aliens. And so this is where we have to be really careful with our own scientific rigor, because if we're too early to jump the gun, and that's actually what happened, is that originally this story got leaked that this message was, or that this signal had been received and that they were doing work on it. And as a result, we may have never even heard of the public that this process was even going on to scrutinize the signal. It may have just been discarded after a year, like all the rest of them. But the signal had been leaked, or the story about the signal had been leaked to The Guardian, and The Guardian published a story on it. So then all of a sudden it became public. And that sometimes might be helpful because then the public gets to see the behind the scenes of how this process works. But it also can sometimes discredit the process, because if we jump on it and say, oh, it's aliens, people are going to say, wait a second here. So thankfully that scientific rigor was done, and we know now that this is not a signal from Proxima Centauri. It's just us hearing ourselves.
And I guess that's also part of the news cycle as well. And you are part of that media, as you are a writer for a website. But as a content writer, if you're working for a news organization and something like this news story comes out, of course you're going to lead with potential aliens, or whatever the story is about is going to be centered around, is it aliens or is it not? And even if it's not aliens, let's still talk about aliens.
Yeah, and when this story came out last year, and so this is a follow-up piece to the original article I had written the year before saying, hey, the signal's being scrutinized, we're looking at it. At the time, it was called BLC1, which is Breakthrough Listen Candidate 1, Breakthrough Listen being the umbrella project that was conducting the SETI research through this signal. And the magazine said, like Universe Today said, when I grabbed it, they're like, make it very clear that it's probably not aliens, because the magazine needs to maintain its credibility as well. And every single time so far that we've seen a signal like this, it turned out not to be aliens. The WOW signal, I think they're still out on that one, but it probably isn't either. So we always usually want to make it clear, listen, we're excited about this, but the process to do the science to determine as to whether or not it actually is from aliens is also as equally important, because otherwise we can't trust the information that we're getting from space.
Well, I don't know about the WOW signal, but I watched their X-Files episode recently. I've been going through it, and they certainly went back and were able to, or at least Mulder was able to find some definitive evidence. I'm not sure if that was actually proven outright or not.
Yeah.
But you did mention a breakthrough, and you said that these signals are coming through something called the Breakthrough Project. And there's another story that came out recently. Just going to share my screen about the Breakthrough Initiative. Maybe just talk a little bit about what that is when you say Breakthrough Initiative.
Yeah, so Breakthrough is actually, there's a couple sub-projects that are under an umbrella project. Breakthrough is funded by philanthropist Yuri Milner, and it's a multi-million-dollar initiative to not only listen for aliens, but also potentially send a probe into deep space, which is part of something called Breakthrough Starshot. And that's actually trying to look at taking like a gram-sized probe, accelerating it on a giant gold sail to about the quarter of the speed of light, and send it to Proxima Centauri, where we're listening to signals from. And at that speed, we could actually get it there in one human lifetime, which is really cool. We haven't quite figured out the technology of that yet. So in the meantime, we're also doing the listening for Proxima Centauri. And now this new project that might be doing observing of Proxima Centauri. Now, Proxima Centauri itself is part of a triple star system that's generally known as Alpha Centauri. We have a pretty good idea that there's at least one terrestrial planet a rocky planet called Proxima b that is orbiting Proxima Centauri. That's why it was exciting when we first heard the signal in that direction, because we thought, hey, like if there's a rocky planet there, maybe there's a civilization, as unlikely it would be to be right next door to us, but maybe. So we're also designing this new telescope now under the Breakthrough Initiatives, and it's called the Tollyman Telescope. And what it's going to be doing is looking specifically at the Alpha Centauri system to see if there are more habitable planets that are there. So we're aware of the one planet, but we don't know if there are others necessarily around Proxima or Alpha Centauri A or B. There may be a gas giant, but we're not entirely sure. And so this telescope is going to use a method called radial velocity. So what it's looking at specifically is the wobble in a star that is introduced by the orbiting planets in that system. So we typically think of the star as being the center of the solar system and the planets kind of orbiting around the outside. But technically speaking, there's a center to the system that's between the gravity of a planet and the star. And as the planet's orbiting around the star, it causes the star to wobble back and forth. And we can see that wobble with our telescopes. It's kind of a telltale sign that a planet exists there. So that's what this telescope will be doing, and focusing specifically on our neighboring star system to see what might be there.
Very cool. And there was also, there's a whole bunch of other people that are involved in this project as well. And I remember hearing when they first announced the Breakthrough Starshot project, that, Andrew was going to be involved, even Mark Zuckerberg. What are their involvements in this whole project?
For this one in particular, I'm not exactly sure. I know that there is always crossover with, for example, the NASA's Jet Propulsion Laboratory is involved in some of these initiatives as well. The lead professor on this one is named Peter Toothill from the City Institute for Australia. And so Australia is primarily where a lot of the research around Alpha and Proxima Centauri happens, because that's the hemisphere of the sky that star system is in. That's why it's the Miryang telescope, radio telescope, which is formerly known as the Parkes Radio Telescope, that is also located in Australia, that was listening for the Breakthrough Listen candidate signal as well. But yeah, as always, when funding for these initiatives comes through, it's always going to branch back out to people who have the expertise, whether it's a pre-established institution like NASA, or say like Berkeley with its SETI Institute, to grab people from that are going to be working to make these discoveries actually happen. So which is all exciting for all of us. And that's a cool thing about the search for extraterrestrial intelligence, is it's done cross-institution, cross-border. SETI is not centralized anymore. It's now happening with different universities, institutions, and initiatives around the world.
Really interesting. And I remember back in, I think, the late 90s, I believe, which was when I first started hearing about SETI, discounting the X-Files connection, but SETI used to do this thing where you could use your computer power to help process some data. Is that something that's still happening? Can people out there actually help SETI with their mission?
So SETI at home has wrapped, so that project doesn't happen anymore, but it was cool because it was like one of the early instances of what we now know as citizen science, that people could participate. So it was, like you're saying, it was a screensaver on your computer is not doing anything right now. Hey, can we borrow some of the processing power to look through data and see if we can find things? Now, of course, we do that as well with supercomputers, but there is a website called Galaxy Zoo where people can go and log on and do a number of citizen science initiatives where basically you're scanning through data to see if you can find anything. And there's a Planet Hunter section of that where you can actually look at light curves from stars that indicate a drop in light from a planet passing in front of our view of that star. And it may have been missed by other data scrubbing. And so you can literally be at home and try to help discover planets, because there's just so much data coming from all these projects now that we need as many eyes on it as possible. And that's why it's cool that more people can be engaged. I think in some ways through these initiatives, science is more open than it ever has been.
Really cool. I'm going to post a link to that Galaxy Zoo project you just talked about in the chat. Of course, everyone that is here, welcome. If you have any questions, we're talking lots about aliens, about search for extraterrestrial life, SETI. If you have any questions for Matthew, put them into the chat. We've got about 15 more minutes to talk about this. We do actually have a question first from Harry, who asks, if the closest star is 4 light years away, 24 trillion miles, Harry's done his math there. At current speeds, vessels would take X years to commute one way. What follow-up could Earthlings physically take?
For us, while we're waiting for it to get there?
Yeah.
That's kind of the question. Yeah, it might be just the weight. I mean, a lot of it is probably going to be monitoring the journey to make sure that the probe is still alive. Remember, we haven't created interstellar probes yet, so this is something that we're still working on. Our most distant object from Earth so far is traveling more at the speed of a conventional chemical rocket that it was originally launched on, and that's the Voyager space probe, the Voyager 1 that was launched in 1977. Voyager is now only 15 light hours from Earth. Never mind light years, and it's been traveling for over 40 years now, but we're still in contact with that probe, and it still sends regular information back and forth. What's revolutionary about an interstellar probe, the one that we're talking about with Breakthrough Starshot, is that yes, it could literally reach in one human lifetime, but all along the way, we're still going to be in contact with it to make sure that it is surviving its journey until it finally reaches there. And you are right, once it gets there and is sending information back, that information is still going to be delayed for 4 years until it finally gets here.
Yeah, so it's a very much a long-term project and something that may not even you see fruition in our lifetimes. You know, you start on a project and you see through it for many, many years, and then you just have to pass along that project to the next generation, right?
Mm-hmm. Yeah, what's cool about this, I mean, we're always talking about, you know, in science fiction, we gloss this over because we have faster than light communication as well as faster than light travel. What we'll probably see as an interim between is we also are starting to see next generation of propulsion methods that are created probably using nuclear fusion, so actually having fusion engines. And we still probably won't be using them to necessarily get humans back and forth from other stars. But we definitely might see a huge decrease in the amount of time to get between planets in our own solar system. So we'll probably see that first, you know, talking like being able to go to Mars in a couple of weeks rather than a few years.
Okay, very, very cool. All right, Matthew. So we're going to get to another article that you haven't published yet. It's coming out. So this is going to be a preview for a really cool idea, an idea that was brought up through other means. I don't think it was originally created in thinking about alien civilizations, but now this thing called a Dyson Sphere is something that you hear about in science fiction, but you're also starting to hear about it through other means as well, is a way that we could potentially find these alien civilizations. Now, first off, maybe just let people know, if they have never heard of Dyson Sphere before, what exactly we're talking about here.
Yeah, so the idea of a Dyson Sphere is actually named after an astronomer named Freeman Dyson. And Freeman Dyson suggested this idea back in the 1960s. Let's say that you're some really, really advanced civilization. And the idea is that the more advanced your civilization becomes, the more advanced your technology becomes, you need more and more power to sustain your civilization. So where is the largest source of power in a given solar system? It's going to be your star. So if you could encapsulate the star in either a swarm of satellites, solar satellites, or in actual structures like solar panels that would encapsulate the star, not entirely necessarily, but large portions of the star, you could draw power directly from the star for your civilization. So it's not a completely it's not a wild guess. It's sort of a logical next step of, well, if someone wants to take a lot of power from space, where do you get it from? You'd get it from a star. So then the question is, well, if people have thought of this, if there are civilizations that advanced, either in other galaxies in our own, would we be able to determine by looking at a star remotely across space that it has a structure around it in some way? And how could you actually detect that?
I mean, it all sounds, you know, all very feasible, but what are the practicalities of actually doing this? Because if we start thinking about a structure, let's say inside of our solar system, it's hard to really grasp just how large of a structure we would be talking about here. Something that's not only encapsulating all of the Earth and the sun, but so much more space as well around this entire structure. Like, is that even possible? Could we even possibly build something that large?
Yeah, for us at our level of technology, probably not. We call this, the term usually for it is mega engineering, right? These are mega structures. So these are things that we're leaving toward the, and it's some advanced civilization that has the possibility to do this. Now, if we look at the physics of it, is the physics of it possible? Yes, it could be done. You probably couldn't completely encapsulate a star because you can't keep the structure centered enough around the star in order for it to maintain itself. But if you're talking like an open kind of structure, very similar to the picture we're showing here, or a swarm of satellites, around that star, yeah, that could be possibly done. It's probably outside the realm of what we'd be capable of doing, but assuming there's some civilization out there, and you got to remember how old the universe is. If there is some civilization, even a fraction of an age of the universe older than us, that's a lot of time for that civilization to be around to maybe develop technology like this.
So you're writing an article about Dyson spheres, and obviously you're not writing a science fiction article, you're writing it from a science perspective. So what are some of the angles that you're taking? Like, is there new developments on Dyson spheres? Are people thinking about them in different ways? Like, what's the connection now to inspire you to write this article?
There's some science research, there's some research that we've done recently that's trying to figure out how we might be able to tell that you could actually determine there was one of these structures around the star. Now, typically the way that was done in the past is we would say, okay, if the star dims in a certain way, we might be able to say that it's an obstruction between us and the star, that something is actually passing in front of it. A star in the news that got a lot of attention a couple of years ago was called Tabby's star. And that was a star that was named after Tabitha Boyajian, who had seen a star that had made a significant drop in luminosity, like a dozen%, or like 20% or 30%. I can't remember the exact figure now, but way more than we would see from just, say, a planet transiting in front of that star. And so when that happened, we thought, hey, maybe it's one of those big solar panels from some megastructure passing in front of that star. And follow-up research suggests it probably was like an interstellar cloud of dust and gas and not a megastructure. Again, it's usually never aliens, right? So far, it's never been aliens. But what about if there was a telltale sign from the star itself, something that happens to a star when it has this kind of structure that would also be visible to us in some way? So the research is being done right now by two individuals. So one is Jason T. Wright, who is a professor at Penn State Extraterrestrial Intelligence Center. Professor Jason Wright does a number of it kind of specializes in what we call artifact SETI. So we were talking about radio SETI before. This is artifact SETI, so actually being able to directly detect it. And he was working with a PhD candidate student named Macy J. Houston, who is actually the lead author on this paper. And so they were looking at like what physically happens to a star when you encapsulate it, because some of the heat from the star ended up being reflected back toward that star. And what happens to the star when that happens? And it turns out that if there's a large percentage of the energy that comes back from the Dyson sphere or Dyson swarm toward the star, it can create a swelling effect on the star and a cooling effect on the surface of the star. So the star's energy gets back to itself. And when that energy gets back through the star, and if it makes it all the way to the core of the star, it can actually slow down the rate of nuclear fusion inside of the star, which sounds counterintuitive. But the thing is, if you add more heat inside of a star, it swells up more. There's less pressure than in the center. There's less of that collision between atoms in the center of the star, and the star begins to cool down at the interior and swell on the surface. So this is another way, besides just the covering of the star from the actual structure, that you might be able to say, oh, there's something weird happening in that star. It's too cold and it is swollen up too much for itself. That could be an indication that there is a structure around it.
Really interesting. I hadn't really thought that adding more heat to a star from an outside source, in this case, its own heat just being reflected back, would actually cool the star. That's really interesting.
Yeah, and what happens is it ends up reducing the rate of nuclear fusion in star. It also depends on the type of star. So tinier stars, they're called fully convective. So when you look at a really, really tiny star, all of the hydrogen is always being churned in it constantly. Larger stars, they call them more radiative. So there's more energy kind of pushing out from the outer layers of the star outward. And so the tinier stars, it's easier to get that heat back down in the middle. So that cooling effect on them is more exaggerated. Larger stars, not as much. So again, it has to be kind of one of those quieter stars, similar to Proxima Centauri, so a red dwarf, that allows the heat to get all the way down inside of the star without it being pushed back by the larger star's energy. So the effect is more exaggerated on smaller stars. But again, this is kind of one of those ways where we're like, I don't know, how do we find something? We put it in a simulator, we simulate the effect, we exaggerate it over a period of time longer than we could ever possibly observe it in real life. And then we put it out into telescopes and see, hey, can we find this? One of the cool things about this, that sort of looking forward to news later, and I know that you've talked about this already online, is that some of these things that we think might be out there and we're kind of trying to figure out how to simulate, more of these confirmations we might be able to do once things like the James Webb Space Telescope launches. So a lot of these things on Artifact SETI that I've been reading about and then writing about myself are always saying, and now we can't wait for James Webb to come out so it can try to prove or disprove some of these ideas that we have.
And we certainly have been talking a lot about James Webb recently. We had a cosmic night a few weeks ago. Hopefully, folks were able to join us for that. Dr. Julie Clavaux from the Canadian Space Agency. Some news came out recently about the James Webb Space Telescope. Of course, it's main news that it keeps getting delayed, and no surprise, delayed again. This time not like super delayed, just delayed a few more days. So now we're looking at what, December 20th now, or December 22nd?
22nd, I believe, yeah. And then there's like kind of an asterisk in there. They said at the earliest. So
right.
Hopefully that's what it's going to be. We definitely all are really trying to put all of our space vibes out there that's what it's going to be. But if they have to take a couple extra days to make sure it's going to go well, they're going to do it. We've already waited 7 years. So a couple extra days just to make sure it's going to happen is not so bad.
Now, one thing that I haven't been thinking about, because when we talk about Mars missions, there is a window of time that if you delay it too much, then you miss your window to go to Mars. Is there a window for James Webb?
There is actually. So there is a launch window for James Webb. But what happens is the windows are more frequent throughout the course of the year. So when we're heading to something like Mars, you have an opportunity to get there. And then that opportunity, once it's gone, you've got to wait for the Earth to kind of come back around and catch up to Mars again. Where the James Webb Space Telescope is launching is to something called Lagrange Point 2. And what it is it's basically like a pocket of gravity that follows along with the Earth and the Moon through space. An analogy we've been using around the Space Center is like, imagine you're on a boat, and when you're paddling through the water or going through the water, you see like these little eddies that kind of follow along with you. And if like foam gets in it or a leaf gets in it, it comes with you along behind the boat. That's kind of what these pockets of gravity are between the Earth, the Moon, and the Sun. And we're going to put the telescope in that spot. So there are a few times where the launch angle is wrong to get to where you're trying to go to. But if you miss one, it usually comes up again pretty quickly. So it's not like Mars where we have to wait a few months or a year again to get it back into space.
Right. So if we miss the Christmas window, then we've always got Valentine's Day, right?
Yeah, so I think they're more frequent than that. I've got to go back and check, but I think we're looking on like usually on average only a couple days between in order to get it up again. Yeah, but if we're talking about holiday time, then I guess that's the next one we have.
Or we could be doing perihelion. We'll be doing another perihelion event online. January 3rd, I believe perihelion is, which is, of course, the closest approach that the Earth takes to the sun. Marley and I will likely be online. We'll do a fun trivia game like we did last year, as well as a whole bunch of events that we're going to be coming your way. You can check our website, spacecenter.ca, for some of those. No big online events except for our Ask Astronomers that are coming up next month in December. Of course, after Christmas, starting December 26th, we're going to be open every day for the Christmas holidays. So go online if you're welcome to, if you want to come in for a visit. Visit Matthew, who sometimes is in the planetarium doing shows. We're also open on those Friday evenings. We've had some clear evenings. I saw Venus recently, so bright. I walked outside of the Space Center and it was already dark, and looking right at me was bright Venus. So definitely go check out Venus. Probably not tonight. I'm looking out my window. If you're in the lower mainland, probably not seeing any stars tonight. But if you're out there along the 49th parallel, bright up there in the south.
This is why we have space telescopes. So we don't have to worry about the clouds.
Absolutely. Anything else people should be looking out for, Matthew?
Well, I think right now the big one, of course, is James Webb. So that's what we're all waiting for. And so that's kind of the big story now. We just had the asteroid deflection launch that happened. So that went off successfully a couple of days ago. I think you guys talked about that recently too. So waiting for that now to collide into an asteroid, which is cool. So that's going on. Yeah, but those are the big things that we're all covering and looking at, and we're all, as all of us, obviously, as space science writers, we're all waiting for those first data points to come in from the James Webb Space Telescope to be talking about that as well.
Awesome. Well, Matthew, thank you so much for jumping in and filling in for Marley while she's on vacation. Everyone go and check out your articles on Universe Today. You've got that new one on Dyson Spheres that's going to be posted, you say, the next day or so. So everyone go out there and read that. And I'll be seeing you all here in 2 weeks. In 2 weeks, Thursday, same time, 2 p.m. Pacific time for another edition of Ask an Astronomer. Thanks so much, everyone.